Hello everybody, in this video we're going to talk about how to identify polynomial functions. So let's first talk about what is a polynomial. It's just a monomial or a sum of monomials. So that brings us to this idea of a monomial. What's a monomial? Well, here in orange we have what a monomial is. It's just a number, a variable, or a product of a number and one or more variables, right? So this could be, 8 or x or 8x, right? Those are our examples of monomials. So a polynomial is going to be one of those monomials or a sum of those monomials, okay? Now a polynomial function is a function of the form, and here in orange we have f of x is equal to, and we have a sub n, x to the n, right? So the a sub n, that's going to be like the number of the term, right? So like the first term there, the degree is going to be our exponent, right? And so here our leading coefficient is going to be our number that we have in front of our variable x, or whatever other variable we're working with. And then our degree is going to be our exponent, okay? And a function in this polynomial, or in the form, in standard form, we want to have our degrees, and we see this down here at the bottom, are written in descending order from left to right. So we would want to have like the fifth power, then the fourth, then the third, then the second, then the first, and then our constant term at the very end. Okay, now we don't always have to have all of those degrees, right? We could have a degree of a 5, and then a 3, and then our constant term. That's okay, all right? So a couple things about our polynomial function. A sub n can't be 0. So we can't have like 0x squared, right? We can't have that because there would be no x squared term, okay? Exponents are all whole numbers, so we can't have an exponent. So let's say, for example, we can't have like 4x to the negative second, okay? Negative 2 is not a whole number. Coefficients are all real numbers, so we just can't have any imaginary numbers as coefficients. And we already mentioned standard form. We want to make sure we're writing our function in order from left to right, descending order in terms of their degree, okay? So let's look at some common polynomial functions here. We have a degree from 0 all the way to 4. So if our degree is 0, that's just a constant function. That would be just f of x is equal to, and here we have a sub 0, and that would be an example of just f of x is equal to 7, right? So if we were to graph that, it would just be a horizontal line, and it's a constant function. For a degree of 1, that's a linear function, and that would be something in slope-intercept form, right? So, f of x equals 2x plus 4, something like that. So notice how our degree, or our exponent there, is not listed because it's a 1, right? And so whenever we have an exponent of a 1, we don't have to write it. Our degree of 2 would be a quadratic function. So in this case, we would have an exponent that is being squared as our highest degree. So our example here would be f of x equals 3x squared minus 2x plus 5. Okay, that'd be a quadratic example. Degree of a 3 would be a cubic function. So here our highest degree is a 3. And notice here in our example, we have f of x equals x cubed minus 2x squared plus 7x. Notice that we don't have a constant term there, right? We didn't end that with plus 5 or minus 2. That's okay, right? We don't have to have all of the degrees, right? We don't have to have a constant at the end for it to still be a cubic function. And the last one we're going to look at here is when we have a degree of a 4. We call this a quartic function. And this would be, for an example, f of x equals x to the 4th plus 3x minus 5. So notice in here, we didn't have a cubic term, right? We didn't have a degree of a 3, and we didn't have a quadratic term. We didn't have a degree of a 2. That's okay, right? It's still a quartic function because the highest degree there is a 4, okay? So let's take a look at 4 examples here, and we're going to decide, first of all, is this function even a polynomial function? And if it is, we're going to write it in standard form, and we're going to state the degree, the type, and the leading coefficient, okay? So for number 1, we have f of x equals negative 4x to the 5th power plus 5x squared minus 2. Well, everything checks out. It looks good. Our coefficients are real numbers. Our exponents are whole numbers. So we're going to say, yes, this is a polynomial function. And let's write it in standard form. Well, it's already in standard form, right? So we can just rewrite it. F of x equals negative 4x to the 5th plus 7x squared minus 2. That would be our standard form. Now our degree here is going to be 5. That's just our highest exponent. Our degree is 5. Our type, we're not going to write the type there because it's past a quartic function. That'll just be a degree of 5. And our leading coefficient here, we'll call it LC. Our leading coefficient would be a negative 4, right? Because our leading coefficient is just the first coefficient that we have when it's in standard form. All right, let's look at number 2. We have g of x equals 0.5x squared plus a square root of 3x to the 4th plus 19, okay? Everything is good here as well. Our coefficients are real numbers, right? We see we have the square root of 3, so it's not a rational number. It's irrational, but it's still a real number. That's okay. And now let's go ahead and say, yes, this is a polynomial function, and we are going to have to rearrange our terms here to make sure it's in standard form. So we're going to go ahead and write square root of 3 x to the 4th plus 0.5 x squared plus 19. So our degree here is going to be 4. So this would be a quartic function. Put that in parentheses there. And our leading coefficient would be the square root of 3. Okay. All right, let's take a look at number 3. We have h of x equals negative x cubed minus 4x to the negative 4th minus 3x. So red flag right away, we have an exponent that is not a whole number. So we're going to say, no, this is not a polynomial function. Okay, and the reason being is we have an exponent. So we have an exponent that is not a whole number. Okay, so that makes it not a polynomial function. All right, in the last example, we have k of x equals x squared plus 9x, or excuse me, 9 to the x power minus 1. So once again, our red flag here is our exponent of an x. So we're going to say this is not a polynomial function. And our reason being is just similar to number 3, right? We have an exponent that is a variable. Okay, so we can't have a variable exponent. Remember, our exponents have to be whole numbers. Okay, and so hopefully that helped you out a little bit on how to identify some polynomial functions. In this video, we talked about a degree of 0 all the way through a degree of 4, and that's how you can identify a polynomial function.